Alright. I think in this stream. Oh, no light. Oops, too much light. Too much light, I said. Yes, better. Better. So in this stream, I will make a priority queue, I think. Like last time I made a hash table in C from scratch. And before that I did dynamic array. And yeah, I think tonight I will just make a priority queue with a heap data structure. Can I turn off the... Yes, too bright. I already implemented this a very long time ago, but I'm still curious on how it works. Wait, you go there, you go there, you go there. Yes. And so the goal is that like a priority queue is like well, a queue, but each element of it has a priority, and the elements that have the highest priority are the, when you pop from the queue, the element with the highest priority is popped first. I think it's used, for example, in like processes. So when like you need a scheduler to schedule tasks on the CPU, and each of those processes has like a priority. Here it's a pri, and so yes, this. So I think lower is better in this case, or maybe it's the opposite. Higher priority. No, higher priority is better. So you can see that the init one is has a high priority, and there is other ones that have a lower priority, and so on and so on. And yeah, and I've used it in other areas as well. Don't remember exactly when though. I think in the A-star algorithm, when you need to like search through a graph, the shortest path, you also need a priority queue. So yep. Anyway, let's do src test. Let's cp. Yeah, I don't know. Think. Oops. Let's kinda retake the same thing as in the previous episodes. So yeah, I have stuff. This guy. I don't know. Prior PQ. Yeah, PQ in French means toilet paper. So let's not call it PQ. Priority queue. Yeah, whatever. Let's just use the full name. Let's use the full name. Priority queue. Yes. And the main one. Priority queue. Executable example. There is no example yet. Okay, so touch test priority queue. Yes. See. Let's change this. See. And so finally we have this, and I can do Maison setup build and Ninja build and this, and okay. Alright, that's the basic setup, and also I forgot to add C-lang format here. Let's do that, and let's redo the muscle thing. Up, Ninja C, build C-lang format. Alright. And also we want to touch C this .h, we want a header file. If and if priority q h Alright, and so the way it works is you have a heap data structure, and this is like, it's a bit strange, but you have like a tree that is represented in an array, actually. And the reason we do this is because the manipulation we're gonna do in that tree are easy to do in an array, and also it's just more optimized to do it in an array for cache locality, I assume. Because in a binary tree like this, you would have pointers to pointers and so on and so on, and the memory would be all over the place. Heap tree-based, heap property. So a common implementation is a binary heap in which a tree is complete binary tree. It's used as such as Dijkstra. That's what I was, or heap sort as well. Heap sort is one of the like n log n complexity sorting algorithms, such as like quicksort or merge sort. So okay, so it's just an array, and I want to make it simple, to maybe make a video later about it, so don't think I want to make that array dynamic. Guess I could like do just type def I think the priority of it is I don't think I need to yeah, I do think I need an element. So I could just have like an endpointer, but like an array of ints, and we would see that it would sort the ints automatically, but I think to make it more like understandable for a real world kind of thing, we're just gonna do type def I don't know actually. Struct priority to lm. And this is in priority, and it has just a car contents. I don't know, does that work? Priority qlm pointer is a priority q that we want to do priority q new, Did I call it new in the other thing? I call it new and destroy. Yeah. Which doesn't take anything and returns a priority queue. Fuck's sake. I hate my editor sometimes. Need to fix that auto completion thing. This takes a void, this is destroy, priority queue, let's call it PQ in the, let's just call it P, I guess. Or just Q, yeah, Q is fine. Actually, I don't know if that, maybe that will complicate things. I don't know if I'm trying to do an educational thing first. Shouldn't I do like an array of ints? Well, let's first try with an array of int. See if I change my mind later. Otherwise, I will just use the priority QLM thingy. But yeah, for now, let's keep it simple, just an array of ints. And I think I need a size t count. Include static lib. Yeah, let's include the static IO maybe as well. Priority queue. Actually, if the thing has like a fixed size, I'm guessing I need to store its length as well. Yep. Or I could do like a weird trick where the first element of the array is always the size itself. But yeah, okay, no, yeah, no, never mind. That's retarded. Let me see. Yeah, let's just do this and let's do size t count. Or maybe length and int data. Yeah, that's not too bad. And so yes, include priority queue.h. This is just again I need a static. Doing this every single stream, but oh well. X malloc. Size t size. I don't know. Void pointer. That is equal to malloc size. If red is equal to null, we do abort. So all the one is written red. Then here we do priority queue. This is equal to malloc size of priority queue. No, x malloc. Yes. It's in we return q of course. And we do q length is equal to length. And we do q data is equal to x malloc size of well, I'm guessing an int times length Okay, and then we have the destroy one, which is just 2, 3. And we do 3, we do this, queue data, and just use the queue itself. It maybe do like a very quick print. So, size ti is equal to 0, I, no, then q length I plus plus. Actually, I do think I need a capacity and length. Because I'm gonna have a push and a pop. And so this is length, no, capacity is equal to capacity. This is capacity, this is capacity. And length is equal to 0. And so this is capacity. And what I will do is just so now it's just integers. For now it's just integers. Like this. And this is q data I. If I is lower than q length printf t is equal this wait no length equal this then we print this. Just want to format it so that it looks like an array, because it's an array under the hood. It's just like a debug print kind of thing. Q length. Then at the very end we just do put string. I think put string adds a new line automatically. We add the closing brackets. We add the closing bracket and we do if this is just length. And we do -1, I guess. We do put c. Is putchar deprecated? Putchar is equivalent to this. I mean, it doesn't say deprecated. Putchar. I'm guessing. F puts s. I think put s, right? A string followed by a new line. Let's just make it explicit, like so. Is that okay? I think it's okay. Okay, so I have a little print. Then I need yeah, I think priority queue push. Priority queue, like so, and I need a pop, which will return an else. Yes. Like so. Like so. And so if I remember correctly, in a heap data structure, so you have your array, and I think the maximum, if it's a max heap, the maximum element is the first element, and then you always do like powers of 2 in the index of the array to get the children. To get the left children, you do isn't it like 2 or 2 times n? I don't remember. Wait. I think there is it's written somewhere. Operations, sure, that's all fine. I remember there is also a sift up and sift down after a pop. Therefore, the given a node at index I, this is an index of the array. Its children are at indices 2i plus 1 and 2i plus 2. Okay, so it's just multiples of 2 plus 1 and plus 2. So at indices 0, it's at 1 and 2. At indices 1, it would be 3 and 4. At indices 2, it would be... At indices 2, it would be 5 and 6, and so on and so on. I mean, it explains it better here. So children of 19 are here, and so on and so on and so on. Alright. So balancing a heap is done by sift up or sift down operations, swapping elements which are out of order, as we can build a heap from an array without requiring extra memory for the nodes, for example. Implementation. Heaps are usually implemented with an array as follows. Each element in the array represents a node of the heap, and the parent-child relationship is defined implicitly by the elements indices in the array. For a binary heap in the array, the first index contains the root element, the next two indices array contains the roots, children. Okay, that I understand. This simple indexing scheme makes it efficient to move up or down the tree. Yes. Balancing a heap is done by sift up or sift down operation, swapping elements which are out of order. As we can build a heap from an array without requiring extra memory for the nodes, for example. Heap sort can be used to sort an array in place. After an element is inserted into or deleted from a heap, the heap property may be violated, and the heap must be rebalanced by swapping elements within the array. After an element is inserted or deleted. Okay. So insertion adds a new element at the end of the heap in the first available free space. If this will violate the heap property, sift up the new element, swim operation, until the heap property has been re-established. So in this image, it would mean that if we put the number like 55 in this array, so at the end after the 7 here, it would mean that it's the left child of 3, which is incorrect. And so if I remember correctly, we need to recursively, repetitively swap the child and the root. No, the child and the parent. I don't think that's it. So sift up. How does the sift up work? Sift. Sift up. Move a node up the tree as long as needed. Used to restore heap condition after insertion. Called sift because node moves up the tree until it reaches the correct level. As in a sieve. Sift down, move a node down the tree similar to sift up used to restore heap condition after deletion or replacement. So yeah, that's what I was kind of thinking, but so if I insert 55 here, 55 should be I don't know. So after 36. Wait, this is strange. This has the highest priority. Not sure how this is represented by. Why is it like a sorted queue, a priority queue? So 100 is the highest. That's fine. But why is 25 there and not there? So it follows like this, then this. Or does it like... Oh, okay, I guess the order of those is like kind of random, or like random, like it's just that this one is, like the left one is always lower than the right one, I think. Oh no, never mind. 25 is greater than this. So maybe it's just like that the top element is always the greatest, but for the other one, we just don't give a shit. Maybe, not sure. Use a tree-based data structure that satisfies the heap property in a max heap for any given node C. If P is the parent node of C, then the key, the value of P is greater than or equal to the key of C. If P is the parent, okay. So the only property of a heap is that the parent node is always greater than both of its children, which is indeed respected here. Okay. I'm in heap, yes. The key of C, the node at the top of the heap with no parents is called the root node. A heap is one maximally efficient implementation of an abstract data type called a priority queue. In fact, priority queues are often referred to as heaps regardless of how they may be implemented in the heap. Yes. However, a heap is not a sorted structure. It can be regarded as being partially ordered. A heap is a useful data structure when it is necessary to repeatedly remove the object with the highest or lowest priority, or with insertion needed to. So okay. So in my example, I had 55. 55 is here, and then I need to just swap it with the parent until both of its children are lower than 55 and the parent is higher than 55. So I need to sift it up once. It will replace the tree, and tree will become the children of 55. Then we check 19. 19 is greater, so I need to sift up again. So I swap 19 and 55. And then we check the parents, and parent is 100, and then it's okay. Okay, so I just move it up the tree until it reaches a point where all of its children are lower than him. Okay, that doesn't sound too bad. And so deletion, so I remove the 100, and so sift down is the opposite, where... What do I do? Sift down. I guess the 36 needs to take his place. And then 25. Okay, so we go down the tree and we replace with the highest children every time, I'm guessing. Yeah, I'm not sure. Binary heap, yes. Find max, insert, extract max, delete max, replace, create heapify, merge, meld, join two heaps to form a new heap containing the elements of both, destroying the original heaps. Size is empty, increase key or decrease key. Delete, so sift down, move a node down the tree. Similar to sift up, used to restore heap condition after deletion of things. So I think insertion, I understand. Extraction, remove the root and insert the last element of the heap in the root. Oh, if this violates the heap property, sift down the new root. Sync operation to reestablish heap property. Okay, I understand. So if we remove the 100, we have to put the 7 in its place and then again do the same thing as sifting up, but it says you sift down, and so you compare 7 is it lower than 19 or 36, and then you pick probably the lowest one. If it's lower than this, or you pick one at random, I guess it's fine as well. If it's lower than this, you replace 19 by the root and so on. Wait, no, you need to pick the highest one. You need to pick 36, so you replace the root by 36 and the right node by 7, and then you compare to its children. 1 is fine, 25 is not, and so 25 comes up and 7 comes here. Alright, I think I understand. So extraction, save down the new root, sync operation to re-establish the heap property. Alright. And so replacement, what is this? Remove the root and put the new element at the root and sift down when compared to extraction followed by insertion. This avoids a sift up step. Oh yeah, I see. Like it's a slightly more efficient way of doing deletion than insertion. Alright. Construction of a binary or diary. Diary heap. Yeah, okay, sure. Out of a given array of elements may be performed in linear time using the classical Floyd algorithm. Sure, I don't think I care, but okay, I think I understand. So, in my very simple case, what do I do? So push. First of all, I do if q length is equal to q greater or equal than q capacity, we just crash because I don't want to worry about this. And here we do if the length is equal to 0, we crash. Okay. Let's not worry about the pop for now. So what we need to do is we do q length plus plus, and we do q data q length is equal to, we need to push isn't datum the singular value, the singular noun for data? Datum. Singular should be plural. Shut up. When it comes to writing yes, just tell me which one is that data is a plural form of datum. This means that when referring to a single piece of information, it should be referred as datum. Okay. My brain is not completely rotting, so it is datum. Datum. Then what we need to do is sift up. So we do size t current index is equal to q length, but before we increment it, and so we need to do we need to divide by 2 every time. So we need to get the parent int parent is equal to so we can do like while current index is greater or equal to 0. So parent is equal to current index, and I think it's divided by 2 minus 1. So to get the children, it's like times 2 plus 1. But it depends like if it's on the right or the left. How do I know if I'm a right children or a left children? I guess I can just modulo. I'm guessing that the left children are always modulo something, so is it an odd number or... So this is index 1, so it's odd. This is a left children as well. It is not odd. Wait, 0, 1, 2, 3, it is odd. 3, 4, 5, 6, 7, it is odd. So I think I can guess if I'm the left or right child currently by testing if the number is odd. Maybe. So to get the index, we do times 2, then plus 1, or times 2, then plus 2. So I'm guessing we need to first do minus 1 or minus 2, and then do divided by 2. So current index, so can we do minus current index modulo 2 is equal to 0. If it's divisible by 2, we do minus 2, otherwise we do minus 1. Yeah, there is probably a shorter way of writing this. And we do all of that divided by 2. Push int datum. Yes. Like so, so we get the parent. Go away. Annoying bug. Thank you. So we have the parent index, and we do if parent. No, that's the parent index, and then we do size t, and we do what do we do? We need to compare it, so but we need to get the value first. I'm a bit sleepy. Q data at parent index, we get the value of the parent node, and then we compare it. We compare the parent value. If parent is let's do a max heap and not a min heap. So if the parent is lower than the Q data current index, then the current, then we need to swap them. Do int temp is equal to. Actually, I already have a temp where Q data parent index is equal to this, and then we do current index is equal to parent, like so. I think that works. But for good, for better readability, I think I will just do current like so. Current, and this is current up. Okay, so I swap the two. I swap the two. Really, we can do if it's greater or equal, we just break because the condition is valid. Otherwise, we swap them. Yes. Yeah, I'm not sure about this way of getting the index, but let's assume it's correct. Okay. So let's say the current indexes would be 1. This would be 1, so this would be 0, and 0 divided by 2 would be 0. So yeah, I would indeed get the parents. Well, actually, let's just quickly do some. So let's say 0, 1, 2, 3, 4. So 4, and I want to get the parents. So in my case, I would do -2, so that would be 2 divided by 2, which is 1, and index 1 is this. So indeed, I get the parent. And if it's this, so 0, 1, 2, 3, I would do -1, so that's 2 divided by 2, that's 1. Okay, yeah, I think my simpleton formula will work. Okay, now we need to implement pop. Actually, we can do like the replace first, maybe. Int dating, where here we do like the return value is Q data 0, and then we do Q data 0, so we replace the root with datum, and then we do the sift down, where we do for, yeah, I'm not sure, like while. So we start at 0, while current index is lower or equal, no, not equal, just lower than Q length. And then we do the sift down, which is the opposite operation of this. So we do size left child index is equal to current index times 2 plus 1. Right, child index is plus 2. We need to do if left child index is lower than Q length, Yeah, I think there is some condition with the length, but let's ignore it for now. We do int left child is equal to q data child index so we have the right child right child value and the left one as well. Whatever, let's just have a very quick macro called max that takes xy and returns x greater than y question mark x otherwise y. I don't know, I know it's kind of useless, but yeah, I don't know, indeed it's kind of useless. Int max is equal to left child greater than right child left child right child. Yeah, I don't know, I just wrote this out of habit, but I guess in this case, since I only use it once, it won't be necessary. And what I do is maybe I should get the minimum. Wait, no, I think I need to get the maximum. I to get the maximum, and then what I do is if max is greater than again, I think I need to current is equal to q data current. If max is greater than current, I think we can break the loop if it's lower. Otherwise, we need to sift down, which means q data. Oh, yeah. Cannot do that. Cannot do that. So this is there. I need to do if left child greater than right child. I have something. And left child is greater than current, then we swap with the left child. Else if to copy those, replace with the right child. This is left. This is right. Then we swap with the right child. Else we break because none of the children are greater than whatever I want. Okay, this is a bit strange, but let's go with it. Data left child index is equal to current and current index is equal to left child. And here we just replace left by right, and we need to return what? Let's not call it red, let's call it max. Sure. And then what we want is queue priority queue pop. Let's touch ignore, and I don't know, because I have garbage in my file completion, We don't want build, we don't want cache. Okay. That's good. So let me go back to priority queue.h. I have a pop, but I also now have a replace. And item like so. Yes. And so pop is just we do max is equal to wait, no. Pop is just what? In I think we take like if I remember the last one, Q data again. We need to wait. This goes there. Q data Q length -1. If I remember correctly. So we get the last value. We get the last value and we return priority queue, replace queue and last. I think that's it. We take the last element of the... Do we need to decrease the length as well? I think I do. I think I do. Okay. I think that's a decent draft of an implementation, at least. I think we still have some problems with checking some index things there. Is it though? Yes, but I don't update current index. I need to do as well current index is equal to left child index. And no, here it will be the right child. But since I modified here and then I check the length here, maybe it's fine. Okay. Yeah, I think that's not too bad of an implementation. I mean, I not tested at all, but yeah. Test priority queue, include criterion test priority queue new priority queue is equal to priority queue new with the length of I don't know 10 and let's just make sure assert not null queue not null queue data. What the fuck? Data assert equal queue capacity is of 10 and let's assert that the length is of 0. Then queue destroy. Wait, no, new. Then let's just do destroy. Queue. this. Alright. Alright, but I think I'm too tired to check the rest of the functions. I will do that tomorrow or another day when I feel like it. It was still nice to try to remember what it was about. What heap priority queue were about. That was nice. So yeah, I think I will just do this. Ceiling format. Yes. Okay. Whoops. Nope. Commit. No, GPG sign. Alright. What would be my to-dos for this? I think just test it and test if it works. Make a few examples. Make a video about it. Then maybe show, I don't know, quickly in the example how like heap sort can be implemented with this. Because I think it's once you have the data structure, it's quite easy to do a heap sort. And yeah. Alright. Shall I play some chess? Is it possible to like edit? Oh yes, you can edit the title of a stream in the middle of it. That's nice. Although yeah, it's quite late. I will just stop here and take back tomorrow. See you.